In section 3.4, we are going to solve exponential and logarithmic equations, but for today, we're just going to start with exponential equations. Okay, so for the first example, actually the 0th example, because it's using the one-to-one property, 27 to the x equals 1/9. If it's possible to write them with the same base, that's always the most efficient way to do it and the easiest way to get an exact answer. I can rewrite both of these with a base of 3. So 3 to the 3x equals 3 to the 3 squared is 9. So 3 to the negative 2 is 1/9. Since the bases match by the one-to-one property, their exponent should also match. So I get x equals negative 2/3. Okay, now for example 1, 3 to the x equals 32. That's not going to have any kind of rational answer. Okay, so I'm going to show you two ways to solve it depending on how you learned it last year or what you prefer. You can do it either way. They're equivalent answers. There's just more than one representation in logarithmic answers. Okay, so some of you learned that because this is a base of 3, the easiest way to cancel a base of 3 is to do the log base 3 on both sides. Okay, so I'm doing the log base 3 on both sides. Now this x, by the power rule, it comes down to the front, and then the log base 3 of 3 is 1, so you get log base 3 of 3 to the x is actually just x. Okay, and this is actually a good answer. This is an exact expression for your answer, and it works like that. Now, some of you learned to do natural log or common log on both sides. I'm going to show you that as well. It's also, well, I'll show it to you. Okay, some of you learned to log both sides, or you could natural log. It's the exact same thing. I'm going to use natural log because it's one less letter to write. Okay, if I do the natural log on both sides, I'm going to use the power rule and bring the x down. So now I have x times ln 3 equals the natural log of 32. So I would get x equals ln 32 over ln 3. Okay, or I could have done the log of 32 over the log of 3. This is an exact answer. WebAssign will take this. I will take this. If it asks you for an approximation, you would put this in your calculator, and you get about 3.155. Okay, so there's more than one way to express these. They are the same. And if you look at this answer here, if I use change of base formula, it turns into this answer. Or I could do log 32 over log 3. All correct, I will take all of them. Okay, because in the past, most people have done it the first way, I'm going to do it the first way, but in class, I might do it both ways, depending on what you guys tell me. Okay, so 5 to the x plus 4 equals 41. Since the base is a 5, I'm going to do the log base 5 on both sides. This method's also good if you are not using a calculator to get an approximation. Okay, log base 5 of 5 to the x plus 4 turns into x plus 4. Okay, I'm going to minus the 4 to the other side. Okay, and then this is my exact answer. This is a nice answer. If you solved it the other way, you might have had log 41 over log 5 minus 4 or something like that. That's just as correct. Okay, example 3, still doing log stuff. Okay, I'm going to isolate that 2 to the 3x minus 1 situation. So I'm going to add the 5 over to the other side. So I'm going to get 9. Okay, now I'm going to divide by 7. Okay, let's see. I'm going to do log base 2. Again, you could do common log on both sides. You could do ln on both sides. Whichever way is easiest for you is fine with me. Okay, now I'm just going to kind of rearrange this till I can isolate the x. Okay, so I'm going to add the 1 over to the other side. 3x equals plus 1, and then I'm going to take 1/3 or divide by 3. Okay, I divided both terms by 3. Okay, this is a possible answer. Some people like to separate out the log base 2 of 9 over 7 and make it log base 2 of 9 minus log base 2 of 7 or something like that. That's fine. If you did common log, then you might have log 9 over log 7 plus 1 over 3. There's multiple representations. Again, I will take any representation that is reasonably simplified and is correct. Okay, example 4 and 5 are going to have a base of e in it. Because it has a base of e, it's automatically going to tell me the easiest way to do that is to use ln. So I'm going to do the natural log on both sides because that's the one that corresponds to a base of e. The ln of e to the 2x comes down, the ln of e turns to 1. And then I could say ln 11 over 2, or you could say 1/2 ln 11. The second one's a little bit nicer, but either one, they're the same answer. Okay, example 5, e to the 2x minus 3 e to the x minus 10. This looks like a quadratic, and it kind of is a quadratic. So I'm actually going to factor this if possible. It is possible. With a 5 and a 2, I can factor this. Okay, now let me think. To get e to the 2x, I'm going to have e to the x times e to the x, because that's x plus x, 2x. To get 10, 5 and 2. Let's see, to get negative 3, I need a negative 5 and a positive 2. Okay, if I set each of these equal to 0, then I would get e to the x equals 5, e to the x equals negative 2. I'm going to solve both of these because it looks like I'm going to get two answers. I'm going to do natural log. Okay, now before I continue, the natural log of 5, that's a good answer. The natural log of negative 2 is a no good because this has to be a positive. Okay, so it's not true that x is ln of negative 2. My only solution is going to be ln of 5. Okay, one last example, but I'm going to show it two different ways because they are different enough answers. But I want you to see it two ways. Okay, the issue with example 6 is there's a base of 3 on the left and there's a base of 2 on the right, which means there's multiple ways to approach this problem. Okay, so I think I'm going to start off by doing log base 3. I could have just as easily done the log base 2. I could have just as easily done common log or natural log. On the other example, I'll choose a different base. Okay, so log base 3 of 3 to the x turns into x. So I made the left side a lot nicer. I'm going to move the exponent down. Log base 3 of 2, unfortunately, is still there. That's okay. Okay, I do want to solve for x, so I want to get the x's on the same side of the equation. So I'm going to actually distribute the right side. So that's x times log base 3 of 2 minus 1 times log base 3 of 2. Let's see. I want the x's on the same side of the equation. So I already have an x over here. I'm going to subtract the x log base 3 of 2 to the left side. And I'll still have the negative log base 3 of 2 on the right side. Okay. Now that the x's are both on the left side, I want to isolate the x. So I'm going to factor the x out of the two terms. Okay, x times 1 is 1x. X times log base 3 of 2 is x log base 3 of 2. Okay, and then I can get the x by itself by dividing both sides. By 1 minus log base 3 of 2. Okay, and then you can leave your answer like that. That's a pretty nice answer. If I had chosen to do the log base 2 on both sides, my answer would not have looked the same, but it would also have been correct. Okay, now I want to rework that problem again. This time I'm going to use common log or natural log. I'm going to use natural log so I can write one less letter than log. Okay, so I'm going to do natural log on both sides. because of the exponent rule, I'm going to bring the exponent down. I still want to get the x's on the same side of the equation, so I am still going to distribute. This is going to end up having pretty much the exact same steps, which is why I'm showing you both ways so you can decide which one works better for you. Okay, I'm going to move the x's to the same side of the equation, so the x ln 3 is good. Let me subtract the x ln 2 over to here, and I'll still have a negative ln 2 over on this side. Okay, now that they're on the left side, I can factor out the x. Okay, and then this is another expression for my answer. If I put both of these in the calculator, I would get the same. So in this case, there's multiple expressions that work. They're all correct. Web is saying we'll take them. I will take them.